Okay, so this is the rule I kind of alluded to in a previous video, but if you have a quotient, a over b, and then you're raising it to some power, m, then every base inside the parentheses is going to get that exponent. So it would be a to the m over b to the m. Now, if you're saying, hey, wait a minute, why don't you subtract the exponents? No, because the bases aren't the same. One's an a and one's a b, okay? So that prevents us from simplifying that more. Okay, so we'll give you some examples. This first one, p to the fourth then, over 10 to the fourth. So both the p, that base, gets a 4 of an exponent, and the 10 gets the 4 as an exponent also. Now, will they multiply out 10 to the fourth? I don't really know. I'm going to go ahead and multiply it out. It'd be a 1 and then 4 zeros. So that's a little trick for multiplying powers of 10. You go by how many zeros are, that's the number in the exponent. Okay, so our next example, oh, it's a negative exponent. So I'm going to use that rule where we can flip that quotient in the parentheses to get it positive. So I'm going to make this n over m to the positive 7. So that's a rule we had back a couple videos ago, but I'm reciprocaling the stuff in the parentheses, and then that takes care of the negative on the outside. Now that's just going to simplify to be n to the 7th over m to the 7th, and we're done because the bases are not the same. So that one's done. All right, the next one looks like we have a little more involved. How many bases are there? Well, there's the 3, the coefficient, this one, and then the a and the b and the c. So we've got to bring that 4 into all of those. So it's going to be 3 to the 4th power, a to the 4th power, b to the 12th power, because I'm going to go 3 times 4, over c to the 8th power, because it's going to be 4 times that 2. Okay? I think they would multiply out that 3 to the 4th. So 3 times 3 times, well, 4 of them is 81. And then a to the 4th, b to the 12th, c over c to the 8th. And that one's done because the bases are different. The a, b, and c are all different. Okay, so we've got one more example. I see a little negative exponent in there. I can either take care of it now or I can take care of it later. Let's take care of it now. So what I'm going to do is I'm going to move that x to the negative 2 down to the bottom to become x squared. So then I'm going to have 3 over x squared y cubed. And all of that has an outer exponent of 3. Okay, so that's going to be 3 cubed in the numerator, x to the 6th, and y to the 9th. Well, 3 times 3 times 3 is 27, over x to the 6th, y to the 9th. And that's going to be the answer. Now, let's say you didn't want to do it that way. Remember I said a lot of times you can do these problems more than one way? So let me show you a different way. I'm not going to do it for every problem, but I will for this one. Let's say you didn't want to take care of the negative exponent. Then you would have had 3 cubed x to the negative 6, because you would have multiplied there, over y to the 9th. But then you would have had to take care of the negative exponent on the x. So then you would have had 3 cubed over x to the 6th, y to the 9th. And then you still would have multiplied out the 3 times 3 times 3. And so we would have gotten the same answer. You just have to be careful. Take it one step at a time. There you go.